This is Mr. Wright. Today we are going to talk about rotations within the coordinate plane. So when you're rotating, there's two directions that you could rotate. You could either go clockwise, which is the direction that a clock goes, or you can go counterclockwise. So clockwise, same direction as the clock. Counterclockwise is the opposite direction. So when we do rotations in the coordinate plane, the standard direction to go that we typically go is counterclockwise. So whenever we talk about 90, 180, or 270, unless I specify otherwise, you always just assume that it's counterclockwise. So CCW, that stands for counterclockwise. So 90 degrees would just be like a quarter turn in a coordinate plane. So if this is like my coordinate plane, just like one turn, that would be 90 degrees. 180 would be like two turns. So 1, 2, and that's kind of what that would look like. So whatever's in that coordinate plane is going to turn twice. And then 270, that's going to be 3 turns around. So it's going to, whatever's in like the first quadrant will kind of move to the fourth quadrant if you do 3 turns counterclockwise. So we have 3 rules for this. So my rules for a 90-degree rotation are going to be the opposite of y, then x. For a 180-degree rotation, so the little r stands for rotation, is the opposite of x, the opposite of y. For a 270-degree rotation, my rule is y, then the opposite of x. So remember the negative, that just means like the opposite of whatever the sign is. So positive becomes negative, negative becomes positive. So I'm going to do all 3 points, A, B, and C, for each one of these. So first I'm going to do my 90-degree rotation. So my rule is the opposite of y, then x. So A prime is going to be, so I do, if 7 is y, I do the opposite of 7. Then the x coordinate stays the same. The opposite of y for the b coordinate would be positive 3, and the x coordinate stays the same. The opposite of y for the c coordinate would be negative 1, and then the x coordinate stays the same. For a 180-degree rotation, my rule is the x and the y, they stay in the same order, but both of those become the opposite sign. So for the a coordinate, it would become positive 5, negative 7. For the b coordinate, they both become positive, so positive 6, positive 3. And for the c coordinate, they both become negative. So that they just become the opposite sign. And now for a 270-degree counterclockwise rotation, my rule is the y stays the same, and then the x becomes the opposite sign. So we write the y coordinate first, whatever that is. So I write 7, and then the x becomes opposite, so it'd be positive 5 instead of negative 5. For the b coordinate, I write the y coordinate first, so I write negative 3. And then the x coordinate becomes the opposite sign, so positive 6. And for the c coordinate, I write the y coordinate first, which is 1. Then the x coordinate becomes the opposite sign, negative 3. So that's how you apply your 3 rules for rotations. Let's just look at a problem to kind of see how this looks in the coordinate plane. So if first, I'm going to do a 180-degree rotation. So my xy rule would be negative x, negative y. So for j prime, this would become positive 5, positive 3. For q prime, it would become 0, positive 1. For h prime, it would become positive 3, positive 5. So if I plot these 3 points, 5, 3, 0, 1, 5, 3, 0, 1, and 3, 5, and connect them, so what we were talking about earlier, so when you do a 180-degree rotation counterclockwise, it's like the graph is turning twice, because every time you turn it, it's like 90 degrees. So this would be like a 90-degree rotation. And then this would be, since I turned it twice, that would be what a 180-degree rotation looks like. So you can see how it matches up with that transformed figure. So that is what's happening within the graph. when it's rotating 180 degrees. The second one, if I do a 270 degree rotation, the rule is y, then the opposite of x. So my new coordinates would be 1, -5. Oh, actually that would be +5 because you have to do the opposite of x. 3, +1. -2, +1. -2, +4. So 1, 5, 3, 1. -2, 1, and -2, 4. And sometimes, like when you do rotations, the final rotation may be overlapping the original figure. Like that's okay, like this one. So this is what a 270 degree counterclockwise rotation would look like. So if you take the graph and you turn it 3 times, so remember each turn is 90 degrees. So this would be like a 90 degree rotation. This is where it would move to a 180 and then 270. You can see after the third turn, it matches up with the original figure. 360, I'm back to the original. So 270 degrees counterclockwise rotation, that's what the rotation would look like visually. And then you notice, like we've been going counterclockwise. If I actually went the opposite direction, if I actually went clockwise, because that's just like one turn of the graph, that would be just like a 90 degree rotation. So like 270 counterclockwise is the same as 90 clockwise. Or 90 clockwise is, or counterclockwise is the same as 270 clockwise. So like there are opposites, the 90 and 270 with clockwise and counterclockwise. Then 180, it actually doesn't matter which direction you go. If you go counterclockwise or if you go clockwise 180, you're going to end up in the same spot. So that's how rotations work.